Good morning, Honorable Sir, Ma'am. I'm Aviral Kumar, a student of grade 7 studying in Kendriya Vidyalaya number 1, Hindan, Ghaziabad. So, I'm here to showcase my project that is Future Smart Village. So, this project aims to revolutionize rural areas using smart technologies and sustainable practices. So, what is the concept of my project? The concept of Future Smart Village is to create a self sustaining, technological advanced rural community. The main objectives are to enhance living standards, promote sustainable practices, and integrate modern technology into everyday rural life. This includes smart farming, renewable energy solutions, and efficient waste management to innovate infrastructures. So now let's take a look of process of creating our prototype. So I started identifying the key components necessary for a smart village. This involved planning and gathering materials such as sensors, solar panels, microcontrollers, and other essential hardwares. Here you can see the initial assembly stages where we integrated the sensors and controllers. We faced several challenges such as calibrating the sensors and ensuring the energy efficiency of our systems. However, through the testing and adjustments, we were able to create a functional prototype. So now let's explore how our prototype works. The Future Smart Village includes a smart farm monitoring system that uses IoT technology to allow farmers to monitor soil moisture and weather conditions on their mobile phone and laptops. An engaging smart farm game to educate users about sustainable farming practices and to make farmers familiar about the app.
So I had made a simulator dashboard that will help farmers to understand the main dashboard. So here you can see the main screen to choose the language. Next the starting screen, and this is the guide dashboard. So here you can see the data and buttons. So in the water pump button, it has a 1 minute timer. After that timer, a warning pop-up will come to stop the water pump. So as you can see, the pop-up has came, and it also has a close button. And if we will like click the reset button, it will redirect us to the main page, as you saw early.
LDR embedded street lights that adjust brightness automatically, saving energy. A solar tracker powered by LDR sensors maximizing energy efficiency by following the sun positions. The road reverse speed breaker and piezoelectric load which generates electricity from the vehicle movement and its pressure. A rain alarm which is paired with a rainwater harvesting system to conserve water. A crop and spoilage detection system to ensure food quality and reduce waste. So, this is the prototype Future Smart Village under IoT enabled Sustainable Rural Hub. I will demonstrate how the various component of this project works to bring smart solution to rural hub. So basically it has three parts. First is smart farm monitoring system, second is energy management system, and the last one is alarm systems. So first let's look at a smart farm monitoring system. Using IoT, this system allows farmers to monitor soil moisture, temperature, and humidity directly from their phones or laptops. Second is LDR emitted street lights under the energy management system. These lights automatically turn on when it's get dark and turn off during daylight, conserving energy. This solar tracker use LDR sensor to detect the position of the sun and adjust the angle of the solar panels for maximum energy generation. Here we have the road reverse speed breaker and the piezoelectric road. These systems generate electricity when vehicle pass over them. Next is the windmill. Is Another renewable energy source in our smart village. It generates electricity using the wind. Last is rain alarm and rainwater harvesting system. This rain alarm and rainwater harvesting system works when there is rain and the sensor detects, it activates an alarm and redirects water to storage system for reuse. In final, we have crop spoilage system. So this system uses sensor to identify health and detects spoiled produce, ensuring better quality monitoring. Now I will demonstrate each system one by one. So this is the smart farm monitoring system. It has temperature and humidity monitoring, motion alarm, soil moisture monitoring, water pump, a relay, and an ESP8266 board. So temperature and humidity sensor sends temperature and humidity and sends it on the farmer's mobile dashboard. The soil moisture sensor does the same thing for the soil's moisture. Water pump is used for irrigation. PIR motion sensor is used for night time to identify the cattle or any animals entering the farm. So now I will show the workings of this water pump for irrigation. So in 3, 2, 1. Uh, So when I will operate the button in the web dashboard, the yellow LED on the relay will glow. As you can see in 3, 2, 1. As you can see here. And the temperature and humidity monitoring, soil moisture monitoring, and the motion alarm sends the live data in the web dashboard. So let's move to the web dashboard. Here you can see three gauges. First for temperature, second for humidity, and the last one for soil moisture. And you can see here two buttons, water pump and PIR motion sensor. And the last you can see two charts for humidity and temperature. So I can control this water pump and the PIR motion sensor button from here, and the PIR motion sensor button or like PIR motion sensor also gives the notification if any motion is detected, as you can see here. Now let's move to the automation of the water pump. So if the soil moisture is below 40%, it will automatically start the water pump, and it's above the 40%, it will automatically stop the water pump. Next is road revolt speed breakers. It uses a dynamo to generate electricity when any vehicle will pass through the speed breaker. Like it's move, when any vehicle will go through it, it will generate electricity using the dynamo. So this is the piezoelectric road. If any vehicle will pass through this road, the piezoelectric plates will generate electricity when they are pressed, as you can see. So this is alarm system. So you already saw the motion alarm previous. So this is a rain alarm. So when water droplets will drop on this drop sensor, it will like send the signal to the microcontroller, and it will turn on the buzzer or the LED, as you can see. So in last we have food spoilage monitoring system. So it monitors the gas released by the crops and tells us about the crop or food is fresh or spoiled. It also tells the temperature and humidity released by the crop. So now, what are the value and use cases? The value of Future Smart Village is immense. It promotes sustainable living, reduces cost, and improves the quality of life of rural inhabitants. Imagine a village where farmers can monitor their crops remotely, where energy is harvested from the sun and roads, and where waste is efficiently managed. For example, a farmer can now ensure optimal crop yield by checking soil moisture from his phone. In conclusion, The Future Smart Village is a step towards a sustainable and technologically advanced future for rural communities. That's all my project. Thank you.